Okay, now we come to the ductility. If we talk about the ductility, what is ductility? I have already made you know many times. So all the things that we have discussed in now, they today in today class, they all have been for the ductile materials. I mean that specimen and everything. Just keeping in mind just one exception, which is this one, compression test. Okay. So ductility. So ductility is the ability of the material to undergo a significant plastic deformation before fracture. It is quantified as, how you can quantify? Percentage of elongation. When you stretch the material, okay, the how much percentage they have elongated. That is one. And second one is how much percentage they have reduction in the area. Obviously, I have already made you know, once you start pulling the pulling your material, okay, a specimen, the length will increase at the same time your area of a specimen will start decreasing. Area of means the cross section area. Okay, because over the material volume will remain the same. Okay, so the volume will same after and before you test. The ductile material can stretch or drawn into the wires. Copper is a highly ductile used in the electrical wire. Okay, so this is example that the uh, copper can be stretched too long without their failure. So it is a too much highly ductile material and it is used in wire. The test method, tensile test method is used. That I have been shown above, which is and which show how along the percentage of elongation and percentage of area reduction. Okay, 10%. Okay. We talk about the procedures. This is the procedure how you can calculate the ductility, the final length minus initial length upon initial length into 100. This is your, I mean, this is just ductility. If you need to, uh, show in percentage, then you just need to multiply with 100. So ductility would become into the percentage. If we talk about the reduction in area, you need to calculate the original area minus the final area divided. Why you are taking the original first? Because you need to take the things in positive. You are just finding out the changes. So in this case, the final area is less, but in length, final area is greater. So you are keeping in that way. So because the change, the word here is the word here used is change. Change means positive minus negative. So whatever the thing is bigger, you need to take it first, right? Original area, so you can calculate the reduction in area.